Thanks. I'll begin with a word of prayer. Dear Heavenly Father, we thank you again for this class. I thank you for these students. We thank you for the break that's about to start. Pray to be with us today. Help us to glorify you in what we do. I just pray that the students would be able to ask good questions and we'd be able to just draw together our understanding for the test which is upcoming after the break. Lord, in your name I pray. Amen. All right, so before I take a question, let me just do a brief overview of what we're doing. So we're studying something like y equals f of x, and we want to study, what do we want to study? We want to study intervals of increase, intervals of decrease, right? What else do we want to study? We want to study intervals of where it's concave up, where it's concave down, right? What are other interesting things that we want to make sure we understand? Of course, we want to know where are there critical points, right? Critical points, we understand where those are, and we also want to know where are the inflection points. Let's see, is there anything else we're interested in? Of course, we're also interested in two other things, horizontal asymptotes. Horizontal asymptotes, and of course, not to be forgotten, vertical asymptotes. These things, along with, what did we learn before this course? Before all this, what do you want to know about? How about zeros, right? These are the things we'd like to understand for a graph. And so in here, our typical example, about the worst the example we get, the kind of the nastiest example we'll consider is a rational function, right? So, typical example, either polynomial or rational function, all right? So that's what it'll be. We already looked at polynomial functions last time. We'll look at some rational functions today. Now, just let me put it in red. What does it mean for a zero? If c is a zero, we have what? F of c equals to 0, right? What's a critical point? Either f prime of c does not exist, right? Or f prime of c equals to 0. That's a critical point. That's also where you have horizontal tangents in the graph, right? Supposing it exists. And so intervals of increase, what's that going to be? That's where f prime of x is greater than 0, right? Decrease, that's where f prime of x is less than 0. How about concave up and concave down? Concave up, which by the way we can abbreviate as CU. Concave down, by the way, we can abbreviate as CD. So what's concave up? It's where f prime prime of x is greater than 0. And concave down, that's where f prime prime of x is less than 0, right? That's how we analyze these things using calculus. What's an inflection point? It's a point where we change concavity from concave up to concave down, or vice versa. I usually think about going from left to right on a graph. That's why I have to say vice versa. Horizontal asymptote, what's that? It's something like the limit as x goes to either infinity or minus infinity of f of x is just equal to like some constant L. That's a horizontal asymptote, right? Vertical asymptote, what's that? The limit as x goes to, say, a from the left or from the right, whatever, f of x is equal to infinity. Plus or minus infinity, really, right? I mean, there's different cases for the vertical asymptotes, right? It might go to infinity on one side. It might go to minus infinity on the other side. That would mean that the double-sided limit doesn't exist. It might go to infinity from left and from right. Then the double-sided limit exists and it's infinity. Lots of different cases in terms of the vertical asymptotes. Now, by the way, horizontal asymptote we will sometimes abbreviate as Ha. Vertical asymptote we will abbreviate as Virginia. So there you go. And then if you want to be more fancy about it, we can put some dots in there. For those of you who are more OCD than I am, you need to put the dots there, fine with me. But you don't have to spell out vertical asymptote. And you don't have to spell out horizontal asymptote. You can say Ha and Ba, and I will know what you're talking about. But you should say these things. Like in your answer, you should explain what it means, what you wrote, okay? And how did we figure out where the intervals of increase and decrease were? What did we use? What was our main organizational tool for both this question and this question? We used the what? We used the sign chart, right? That's what we did. We used a sign chart. We either looked at f prime of x and we put the critical points, right? Or we looked at f prime prime of x and we put the possible inflection points. You know. And look where it's plus and where it's minus, and that tells you where it's up, concave down, or increasing or decreasing. Okay, so that's what we did last time. That's the theoretical overview. Now that I've got that out of my system, right, because I introduced these concepts in the middle of examples, so I just wanted to go back over it one more time. Put all these things together, you can draw the graph pretty well. So you had a question about your homework before you have to get your plane, so go for it. Homework 8, number 2. So homework 8, number 2, you've got, for me, I've got f of x is equal to 2x squared minus 10x plus 8. All right, so I'm asked to calculate the differential and then to use it to approximate dy and change in y. So a df is equal to f prime of x dx. So what is that? Well, 4x minus 10 dx, right? So there's the differential. That's part A. You got that one, right? You got that, yeah? Yeah. And then B, you're supposed to use that to approximate dy. You're given that x changes from, let's see, x1 is equal to 2, and x2 is equal to 1.97. So the change in x would be minus 0.03, right? It says it changes from 2 to 1.97 in my problem. Yeah, sorry. So dy is equal to f prime of 2 times the change in x. So let's see here. What's f prime of 2? Yeah, negative 2, because that's 4 times 2 minus 10, which is equal to minus 2. So I get minus 2 times minus 0.03, also known as 0.06. There's the approximate. That's the approximate change in x, because what you're doing there is you're replacing this nonlinear function with the linear tangent line, and you're looking at the change along the tangent line by doing this. Now C says to actually straight up calculate the change in y. Well, the change in y here, what that would be f of 2 minus f of 1.97, which would require considerably more arithmetic on my part. I don't have a calculator with me. I won't be able to do this. But at least for this one, it's the same. It says round your answer to 2 decimal places. They're equal. So probably it's the same for your problem, that they're equal. But I mean, technically speaking, they're distinct. in the sense that the change in y really should conceptually be 2 times 2 squared minus 10 times 2 plus 8 minus parentheses 2 times 1.97 quantity squared minus 10 times 1.97 plus quantity 8. Of course, the 8's cancel, but other than that, it's just kind of, I need a calculator. Yeah?
How are we supposed to know that dy equals the derivative of f of 2 times the delta x? How are we supposed to know that?
Again, this is what this is it says use your result from 8 to find the approximate change. So this is how to use the differential to find, this is a little technique, let's say, to approximate change in y by the f. We use dy equals to f prime of a times delta x, add x equals to a, all right? Now, dy and the change in y are different. This is not equal, but that's approximately the same. I can draw a picture of what's going on. The idea here is something like this. Here's the curve of the function. So you pick some point A, right? And here's maybe a plus delta x. So the tangent line to that would be like this, right? So this right here would be the so-called dy, whereas the actual change in y has to do with the difference of the values of the function. Uh-oh. And that would be like here. So again, dy would be f prime of a times delta x, whereas change in y would actually be f of a plus delta x minus f of a. And these are different things. That's actually the honest-to-goodness difference in the function between the 2 points. This is an approximation to the difference built on just multiplying the change in x by the slope of the tangent line. Well, I asked you in homework. So, I mean, the instructions of the problem should make it clear that's what you're supposed to do. It says use your result from part A to find the approximate change in y if x changes from 2 to 1.97. So, I mean, I will tell you this, it's not my favorite thing. But because it actually requires me to get out a calculator. Oh, I think this one's dead. Oh man. I was sad. Yes?
I have a question on C. You have it right there for
Mm-hmm.
number 2. So you have it f of 2 minus f of 3 at 1.97. But over there you have it a plus the change of x. So should we find f of 2?
Oh, yeah, I'm sorry. I should have said... Which one? 2... you're right. You're exactly right. I have this... Well... I don't know. I mean, do you want to base the approximation on the first point or the second point? I say you base that on whichever one's easier. I mean, the whole point is being lazy to approximate the change by picking a point. So if you're going to be lazy, you should use 2 instead of 1.97. Either way, the slope is really, really close to minus 2. I actually don't see what's your question again?
For the change of y, you have f of 2 minus f of 1.97.
Yeah.
Over there in red, you wrote change of y f of a plus change of x.
Yeah. Oh, okay.
So
So you're saying A is... I think A is equal to 2 there, though.
yes, but then it's also plus the change of x. So it would be 2 plus.
Oh, so you're saying I should have a minus here, basically, to be consistent? One way to look at it.
Well, you have it f of
Right, right. So what I'm saying there is f of 2 plus change in x here.
Which really wouldn't just be f of 1.97.
Yeah. Okay. Yeah, I'll take that. Just to make it precise, let's do that. So I just put the minus here, basically. It flipped the order, so.
Okay.
Yeah. That actually is important because I'd get the wrong sign, which would make it quite quite different. So thank you for that question. Sorry. There's something that's messing with my mind about the change in x being negative. It's flipping, it's messing with my intuition. What was your other question?
Number 8.
In homework 8? Come on. Come on. Ah. Perfect. I'm glad you asked this question. This is a good example to exhibit these things. So let me go ahead and erase. So number 8 is actually a pretty healthy version of this general problem we're trying to attack, which is to graph a function, a rational function, using calculus. Now the question is more precise than that. And if you don't mind, I'm going to change this to a function of x. I'm going to rewrite this as g of x, if you don't mind, just in order to make it more comfortable for you guys as I work this example. Because if I work in t, it just makes it less, oh, that's a square, isn't it? I don't want to make that a 4. That would make this a very different problem. That's a square to the plus 4. Okay, and we're supposed to find the intervals where the function's increasing and the intervals where it's decreasing. But I'm going to take that question and add a concave up, concave down, critical points, vertical asymptotes, horizontal asymptotes, everything over there. Inflection points, let's find the whole shebang, if you will. First of all, are there any zeros to this function? Let us start with the precalculus. So if I say g of x equals to 0, that gives me 0 is equal to 6x over x squared plus 4. What are the solutions to that? This denominator, is it ever 0? No, it's x squared plus 4. The smallest that can possibly be is 4. So this is equivalent. Nothing is lost by saying 0 is equal to 6x. So therefore, x equals to 0 is the only 0. In other words, the graph crosses the y-axis at 0 and nowhere else. Right? Now, how about vertical asymptotes? That's also something we can see from the beginning. That basically is the question, is the denominator ever 0? So in other words, x squared plus 4, does this equal to 0? No. If you try to solve that, you get x is plus or minus 2i, whatever that is. So, no vertical asymptotes. Yay. And let's see here, while we're at it, how about horizontal asymptotes? What's the horizontal asymptotes for this function? In other words, what's the limit as x goes to infinity of 6x over x squared plus 4? And while we're at it, let's do plus or minus infinity, since we can do them both at once and save ourselves some writing. In this case, oftentimes you can. What are the rules for thinking about the limit at plus or minus infinity? What do you? Infinity and 7 get into a street fight. Who wins? You're like, I don't know, 7's training. I can't answer this question. Right? I mean, no. Infinity wins. So, I mean, look at this. I mean, well, maybe that's the right thing to say. How about, but this would be like infinity squared plus 4 is the same as infinity squared, right? I guess you've got an infinity upstairs, so it's kind of like infinity over infinity, but just to make it super obvious what happens here, if you divide the top and the bottom, right, by x, we get 6 over x plus 4 over x, right? What happens to 4 over x as x goes to plus or minus infinity? This goes to, so this piece goes to 0. So the whole thing is essentially like 6 over x for x very, very large, either in the positive or negative direction. So the whole thing is just 0. So that tells me we have a horizontal asymptote of y equals to 0 for x going to infinity and for x going to minus infinity. In other words, the left and the right horizontal asymptotes are both y equals to 0. Okay. What's next on my list? Finally, the homework question, intervals of increase and decrease. How do you figure that out? And by the way, actually increase, decrease, and critical points, these are a package deal. Because you need to know the critical points to set up the sign chart, right? This C1 and C2, these are the critical points. So I have to calculate the derivative of g of x. Can we do that? G prime of x is what? Oh, okay. So 6 times x squared plus 4. Now you guys tell me what I did once I do it. Minus 6x times 2x, all divided by x squared plus 4, quantity squared. What manner of dark magic is that? Yes, the old quotient rule it is. These little stirry straws, they don't really stir. The end of it was much more sugary than the start. It is the good part, that's true. I'll take that. Do you agree with that? Now, I remember I told you differentiate and no need to simplify. I now retract that statement. Now I say differentiate and simplify. Because if you don't simplify, you can't analyze the expression, right? So what you're looking for are common factors and anything that's nice in terms of the pattern here. Let's see here. So what is this? I got 6x squared. I'm just going to multiply out plus 24 minus 12x squared, all divided by x squared plus 4 quantity squared. So what happens here? Yeah, I got a minus 6x squared, right? Plus 24, and you're like, I can factor out a 6. I totally agree. I'm just going to write down all the steps because otherwise I'll lose people. So, like, that's really, can I factor out a minus 6? Would that be okay? Minus 6 times x squared minus 4, right? You with me? Oh no. Yeah, well, if you had a plus 4 there, that would just that would mess everything up. Yeah. That would be what kept you in the dark, because that being a minus is so important, because now it's the difference of perfect squares, and it factors into minus 6 times x minus 2 times x plus 2 over x squared plus 4 quantity squared. So you can tell me now, what are the critical points? Critical points at x equals to, plus or minus 2, right? And the denominator here is harmless. Generically speaking, you got to look for where the denominator could be 0. If it was 0, that would give you a place where the derivative is not defined. And that can happen. If there's a vertical asymptote in your original function, there will also be a vertical asymptote in the derivative function. They're preserved under differentiation. And so now I draw my sign chart. Do, 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 do. And here's my f prime of x. And my critical numbers -2 and 2. Make sure you put them in the right order. If you put them not in the order of the number line, that messes up the logic. I've done that before. Don't do that. Yeah.
Can you always put a 0 in between them, or
Can I put a what?
can you, for this sign chart, is it okay if you, like in between -1 and 2, is that okay if you always add a 0 in between, or is that?
I mean, I wouldn't advise it. You just want to pay attention to where the derivative can change signs. I mean, the 0 is somewhere in there. If it's not one of the tick marks, you can use it as a test point. So let's do that. If you check f prime of 0, what is it? You get 24 over 16. It's positive is the point. So it's positive up in here. These factors appear linearly. There's their first power. They're not squared, so that you're going to get a sign flip if you test other points. If you don't believe me, you can check a point other than 0. You could plug in 3 here. You'd get plus, plus, minus, so you get a net minus. If you plug in like -3, you get minus, minus, minus. 3 minuses make a minus. The denominator I can ignore. That's always positive when I'm thinking about the sign of this expression. And now we can answer your question. It's increasing. It's increasing on -2 to 2, and f is decreasing on -infinity to -2 and 2 to infinity. Okay? Yeah. If you guys don't mind, I'm going to bail on the concavity on this example. I mean, we could also go and ask where is it concave up and concave down, but that would take us another 5 minutes on this example. Yeah.
For homework number 8, question number 12.
Okay, I'll come right back to that, but let me graph here before we get to that.
Oh, all right.
Yeah, you're fine, you're fine. I was kind of giving the impression we were done, but I should actually take a second to graph. Now, there is one other thing. What's the sign chart from 0? That's kind of... So if you plug in negative, it's negative. Plug in positive, it's positive. So apparently it crosses from negative to positive. And let's see here. This makes -2 is a what? It's a local, apparently a local min, right? Because it changes from going down to up. It's a local min. And over here, we have a local max, right? Because it goes up and then down again at 2. It's horizontal asymptote, so it's something like this is the graph. Now, if I had done it right, I would have put the 2 right at the top of the... I should have put my numbers in after I drew the shape. So that's the graph, something like that. And you can see, I think there's like a point of concavity. There's got to be a point of concavity in here somewhere. There may be, I don't know. Let me not do that. Number 12, yeah. Do you guys, can I erase this? Have a good break. Hey, wait a minute. Don't we have school tomorrow? Yeah. Hey. Just kidding. Oh, I hope you got all that, because... Oh, well. So number 12. Here we're given h of x is equal to, what is it? 1/2 x to the 4th minus 27 x squared plus 108x minus 7. And we're supposed to find the relative max min if there is any. All right. So what's your question? Just how to do it, or okay? So I'm not asked to graph it, so I'm going to forego some of this and just stick on task. To find relative max or min, I really just need to find the first derivative. If I can draw the sign chart for f prime of x, then I can look at that and use the first derivative test to decide whether it's relative max or min like we did. That's all I really need. So first thing I have to do is figure out the critical points. So to do that, I calculate the derivative and set it equal to 0. That's what? 4 times 4. That's 2x cubed, right? Do you guys agree? Do you agree? First, this gives me what? Minus 54x plus 108. And I'm going to set this equal to 0 for critical points, right? I can't spell. Critical points. All right. Divide by 2. X cubed minus 27x plus 54 equals to 0. Right? At this point, I tilt my head, I squint, and I go, now I was going to say 3 is a solution, but 3 is not a solution, is it? Is 1 a solution? Nah. How about 2? 8? Nah, it's not going to work. What does 3 give me? 3 gives me 27 minus, no, that's not working. Let's see here. How about 4? What happens when you plug in 4? 4 cubed is what? 64? What's 64 plus 54? It's 112? 108? What's 4 times? Oh, 4 is a solution. 4 works. Plug in 4. 4 cubed minus 27 times 4 plus 54 is equal to, that's 64, right? That's equal to 108 minus 108, which is equal to 0, right? So I get 64 plus 54, which is 108, I think. Or is it 118? 118, rather. What's, or is it 116? Aw, stink. I wanted that to work. Aw, man. Yeah, that's 118. That's not a solution either. Curses. Man. It's a cube. I wish it was quadratic. If it was quadratic, we own it, right? I mean, it cannot escape our clutches if it's quadratic. But cubic, I don't know. So my usual approach with cubics that are built from homework questions is just to plug in small numbers until I find one that works. Once I find one that works, I can pull out the factor. Let me just I don't know. The factoring, you know, we get this idea that factoring is easy, right? Because the problems were given factor nicely, but the cold hard truth of mathematics is that factoring is generally difficult. Now this may or may not be one of those examples that's genuinely difficult. I just don't see the solution just yet. What happens if we plug in 5? 125? Negative 6? Negative 6 gives me minus 216, minus 27 times minus 6 plus 54. I really wish I brought my calculator today. Curses. Does this work? Oh, okay. All right, so that means that I can take x plus 6 and divide it into x cubed minus 27x plus 54. Oh, I don't need a calculator now. Now that you give me a solution, I'm fine. So x plus 6, this is x squared. X cubed plus 6x squared, subtract. I get minus 6x squared minus 27x plus 54. So then I do minus 6x. That gives me minus 6x squared minus 36x. Subtract that. That gives me 9x plus 54. So I hope I add 9. And that gives me 9x plus 54. Remainder 0, yay. Okay, so this little bit of long division tells me that my cube is equal to x plus 6 times x squared minus 6x plus 9. Now that factors into x minus 3 quantity squared. The difficulty of this problem is that a cubic is hard to factor unless you have some insight, right? So if I was to ask this question on a test, I would give you a little help. I would give you a little push in the right direction. I would say something like, it may be useful to notice that 6, or rather minus 6 is a critical point for this function. See, because if I just told you that f prime of minus 6 was equal to 0, then all of a sudden it becomes not so bad, because then you know that you can pull out the x plus 6 factor and you have hope to do the algebra. This would still be a challenge problem, even in that context, though, because just the factoring of the cubic is nasty, right? The algebra here is a little bit hard. Okay, now we have the algebra done, though. What are the critical numbers? X equals to minus 6 and 3 are critical, right? Those are places that you've got a horizontal tangent. And then we draw the sign chart. Put in our handy-dandy critical points. So f prime of x was what? After the dust settles, it was 2 times x plus 6 times x minus 3 quantity squared. So I've got one critical number at minus 6. I've got the other one at 3. This is actually a very nice example because it gives us a place where we don't flip signs at the tick mark. Let's see here. You guys start me out. Pick a test point, any test point. What do you want? Negative 10? All right. If I plug in minus 10 here, what do I get? Minus, plus. So altogether, negative. What's something between minus 6 and 3? How about 0? Yeah, 0. I like that. Plug in 0, what do you get? Positive, positive. So pluses.
Where did you get the 2 in front of it?
Oh, I divided that up here. because I just didn't feel like working with twice as big numbers as I needed to. I don't know, sometimes when there's a 2, it's hard to see it a factor, but when you get rid of the 2, it becomes easy to see how to factor. I don't think that was really the case here. It's just an intrinsically kind of, not so easy thing to factor. So you guys, what's the point beyond 3? How about 5? Okay, I'll take that. 11, 4, positive, right? Check that out. Now the reason the derivative did not change signs at 3, right? What's that mean about 3? That means 3 is not a local max or a local min. It's like the cubic function. Remember the y equals x cubed? Looks like this. So the derivative was 3x squared. You see the derivative is positive? It's positive. So here's a critical point, but it's not a relative max or min, right? It's what's called a saddle point. 3 here is a saddle point. It's not a relative max or min. But minus 6 is a what? Yeah, f of minus 6 is relative min. Yeah. I'm kind of scared to find out about concavity here. Let me just try. Why is concavity automatically less scary for a quartic function? In fact, I can safely assign you, find the intervals of concavity for a quartic function without checking the problem ahead of time. I could just make up a thing and say, you guys find the intervals of concavity, and I know it's within your grasp. How do I know this? It's what? It is true. If it's next to the fourth kind of function, it's either like pointing up or it's pointing down. That's true. But the more interesting thing is what? If I generically have ax to the fourth plus bx cubed plus cx squared plus d, right? If that's my f of x, right? Then what's f prime of x? Yeah, right. The second derivative is what governs the concavity, exactly. And what is the thing about the second derivative? Right. That would tell us possible inflection points, right? So what is this? For if I give you a particular ABC. This is a quadratic equation, which means you can use the quadratic formula to find out where it's 0. So much unlike this. There is a cubic formula. It's like a page long. My wife derived it in high school for some reason. She did not go to high school on this continent. Okay, let me remove this. Oh, so guys, I might ask one question on the test which involves long division, but I probably won't ask 5. It is something I think you should be aware of and should know from college algebra, but I'm also quite aware of I'm quite well aware of the fact that most of you don't know it. And since, I already have enough points and I don't want to take more of yours, I don't typically ask too much about it because it would be depressing. Okay, now, so what's h prime prime of x? We already answered the homework question, right? But to find concavity while we're at it, what would we do? 6x squared minus 54. So it's kind of funny, but it's actually easier to figure out the intervals of concavity than the intervals of increase and decrease for this function, right? So let's see here. If I set that equal to 0, what do I get? So x is equal to? Yeah, plus or minus 3. So if I make my f prime prime of x chart, this is a parabola which opens up, so it's going to look like this. So this function is, it's concave up on minus infinity to minus 3 and 3 to infinity. It's concave down on minus 3 to 3. There are two inflection points, right? There's an inflection point at minus 3. There's an inflection point at 3. Are there any vertical asymptotes or horizontal asymptotes for this function? No, as x goes to plus or minus infinity, it just gets really big both ways. So the function goes to infinity at plus or minus infinity, and it's got no vertical asymptotes, right? There's no division by 0 in this formula. So what's the graph look like? See, this is kind of instructive. It's decreasing to minus 6, right? Do you want to find the zeros of this function? I don't. Do you notice how much, every time you go up, like to find the zeros, I'd have to solve h of x equals to 0. Ugh. I really don't want to do that at the moment. It doesn't matter though either, because f of minus 6 is relative minimum. So, you know, roughly speaking, it's got to do something like relative minimum, right? What happens at minus 3? Oh, no, it changes concavity, right? So it changes from concave down, it changes from concave up to concave down, right? And then what happens at 3? At 3 is both a critical point and an inflection point. That doesn't have to happen, but it did here. And so at 3, it's a critical point. It's got a horizontal tangent, and it's also where it changes to concave up. I actually don't know where this is. I mean, I know it's minus 6, f of minus 6, or rather h of minus 6, but I don't know what the value of h of minus 6 is without plugging in minus 6 into that formula. I don't really want to do that because I don't have a calculator, and it would take me a while. But that's the shape of the graph, given the data that we have. See how it works? Concave down here. Let me make the concave down part green. Here it's concave down. There's a critical point here, which is not a relative max or min, it's a saddle point, right? Because the derivative plus, 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 plus. And at minus 3, it changes from concave down to concave up over there. So, anyway, sorry, I should stop trying to make your homework harder than it is. But I think it may be insightful. I hope it is. I do intend to ask you a question or two that are like these examples I'm doing, so I hope you're trying to figure it out with me. So your responsibility for the test is to understand this, right? Now, I will chop it into pieces, right? I might ask you about little different pieces of it, but that's the big idea. And I might ask you at least one question on the test, which is the whole thing, you know? Take it all, put it together, make a graph. So, okay, next question. You guys must have a question. Are you guys good on the ones that actually have pictures? Do you need me to do something that's like one of these picture ones, but different? If there's one you're having trouble with, you just had to guess blindly until you got it, I'd like to know about it. I can help you. I mean, I'm aware you have 15 tries. It's a multiple choice question, so if you don't get it, no offense, but you're really dumb. I mean, come on. But randomly clicking it until you get it right is not the same as understanding it, right? So, 4 of which one? 4 of 8? Sure. Ah, the picture one, huh? All right. You got the same picture? Okay. Here's the moment I'm sad I did not bring my computer with me today. Now I must foolishly attempt to recreate this graph. All right, here goes. $12. 9. 7. 5. 3, and it starts at 1. Looks like that's at 3 to me. The top thing here is 6. All right, so there's a... Now your question was, you're supposed to refer to the following figure and draw the sign diagram for f prime and find the relative extrema of f. All right, so let me try to draw the sign diagram right underneath it. Here's 12, 9. These are not tick marks, right? These are just, I'm just lining up the numbers. So let me use a different color for the tick marks, okay? All right, so where are there critical numbers? Where is there either the derivative is undefined or it has 0? Here, right? Horizontal tangent right there. Oh, where here, right? 5. There's like a whole, it's flat. It's like flat in here. So wherever it's flat, there's just, I don't know how to even draw it. I mean, we haven't talked about that, but it's all 0 there. So, I mean, I don't even know how to express it in the diagram at the moment. That is a critical point. It's not 0 there, right? So right here, f prime of 9 is not existing. Because it would look like it's positive from one side. It would look like it's negative from the other side. You can't have both positive and negative, right? So if there's a kink or a corner in the graph, the derivative does not exist. All right, we good? And then signs. That's easier. What do we got? It's increasing here. It's decreasing there. Increasing. It's constant, right, on that little snippet, right? And then it's increasing again, decreasing. And there it is. Now, what was your question about now that I've gotten this far into the problem?
I don't know. There was an option to put horizontal tangent.
Ah. See, I wouldn't even know what to say about horizontal tangent here because it's just not enough of the graph. You know?
X equals 7 is the horizontal.
Oh, okay, so, all right, fine. So horizontal tangent for the author tan is equivalent to what I said, constant. I introduced the term constant. He says it's got a horizontal tangent where it's constant, which is reasonable, right? I mean, the function's horizontal there, and the tangent to the function matches up. I mean, the function is its own tangent line right there. Like, what happens if I draw the tangent line right there? Right? So it's matching its own tangent line. The tangent line has slope 0, but it's a horizontal tangent. So, but in terms of the language I introduced in here to start with, I said it was constant. So, yeah.
Wouldn't it also be horizontal tangent line at x equals 3 and x equals 5?
But the function is not see, if I look at that, then as soon as I get off the point, I'm not on the tangent line anymore.
So that's why you consider it a relative and a relative maximum.
So I would prefer to say that the function's constant, where he says it's a horizontal tangent, but whatever. Tomato, tomato, whatever it is people say these days. How many of you here actually know who Rush Limbaugh is? Show of hands. 1, 2, Rush Limbaugh. 1, 2, 3, 4, 5, 6. How many people are here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 22. So did I say 6 knew who he was?
Yeah.
So about 35%. I was curious. I was shocked that I had 2 students who didn't know who he was. I mean, you can be before or against, whatever, but he's like a very significant figure in conservative media. I thought maybe people... It's interesting to me that people don't know who he is. Curious. Sorry, I don't know why I got off on that. I was intending to ask at some point. I'm interested in collecting survey data in my classes to find out what's the local awareness of Rush Limbaugh. I mean, this is Liberty University. It's hard to find a much more conservative campus. I mean, Hillsdale, maybe Grove City, I don't know. What's more conservative than us politically? I mean, I think in terms of other things, we're probably more conservative than those places, but politically, I think we're somewhat conservative. I don't know. I mean, this is the birthplace of the moral majority. What is the moral majority? How many? Show of hands. Who here knows what the moral majority is? Who here does not know what the moral majority is? There's no shame in this. Okay. Don't worry. The moral majority is this coalition of, I don't know who. What do you want to say? Political powers, groups of people who banded together and helped get Reagan elected, among other things, back in the 80s. People with crazy idea like marriage between a man and a woman and stuff like that. Yes? Homework number 9. I would love that. I would find that delightful. Which one would you like to know about? I was wondering when you guys were going to ask me about homework number 9. It is due. Number 8. The second derivative test. Let me tell you right here, this example, before I erase it, I told you that f of minus 6 here was a relative minimum because we looked at the sign chart over here, right? And we got it's going from minus to plus, so it's relative minimum. Another way you could have done it, I've erased the stupid formula, but if you had h prime of x was what? What was it? It was 6x squared plus 54? Minus 54. Okay, good. So if you calculate h prime of minus 6, what do you get? $216 minus 54, I guess. I don't know. Big number. Let me just say it's positive. So if the second derivative is positive at the point that's a critical point, the second derivative test says it's a local minimum, or it's a relative minimum in the language of your text. So that's a second derivative test. We basically look for critical points, and we check the concavity at those points. If it's concave up, it is a local minimum. If it's concave down, it's a local maximum. So let's work your problem. Number 9, was it? Number 9. Oh, number 8, okay. Homework 9, number 8. G of x is x cubed minus 9x. And we're supposed to find the relative